Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about word problems.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. It takes Kali 8 minutes to sweep a porch. Shauna can sweep the same porch in 11 minutes. If they worked together, how long would it take them? So let's break down what we know. This work that Kali did of sweeping the porch, we don't know what her rate is, so we'll call that her K, or K for Kali. But they told us here that it takes 8 minutes, right? 8 minutes for her to do that. So Kali's rate times 8 minutes gives us the work that was done. Shauna does the same thing. They say Shauna's work was called S. Her work rate times 11 minutes completed the job. Okay? So we have these two formulas here, or equations, but we need to find something else. The last thing they tell us here is, if they work together, how long would it take them? Okay, so what happens if they all work together? So the job W, sweeping the porch, is still the same value, but working together, we combine their work rates, K plus S. And then we want to, and the formula is multiplied by some time, T, and we're going to find that. Okay, so what do we need to adapt here? Well, the first thing I'm going to adapt is I'm going to take, we can see K times 8 and S times 11 both equal our work W. So if we set them equal to each other, so let me separate this out here. K times 8 is equal to S times 11. And now we're going to use this to solve for K. So Kali's rate, we divide both sides by 8. I'm going to reorder this, but K equals 11/8 times S. And that's going to be crucial. So now what we're going to do is we're going to take this information and plug it into this equation. And we're going to solve for T. But we're also going to change W, okay? W in terms of, S. So W is equal to 11S, or S times 11, however you want to write it. I think it's easier this way right now. And then instead of K, we're putting 11/8 S plus S times T. And now we're going to solve for T. You'll see that something happens here. So 11S comes down, and 11/8 S plus 1S, that's a 19/8S, and we're still multiplying that by T. We divide 19/8 to both sides, or 19/8S, to both sides. The S's cancel, 19/8 cancel here. These S's also cancel. And that leaves us with T by itself, and it's approximately 4.63 minutes. And so if they worked together, they could sweep the porch in approximately, our final answer here, 4.63 minutes. We're given this problem right here. It takes Heather 7 hours to pour a large concrete driveway. Alberto can pour the same driveway in 8 hours. How long would it take them if they worked together? So let's break down what we know. Okay? We know, the work, whatever that work is, which is pouring a large concrete driveway, Heather's rate times time, and time is 7. So the work done is equal to Heather's rate times the time it took her 7 hours. Alberto does the same job, and his rate is 8 hours. So now we have two little equations here, okay, that we can use later. Now lastly, they ask us here, what would it take for them if they worked together? So that same job is going to involve them working together, so both of their work rates added, H plus A, times some time T, which we want to find. So, what can we do? Well, H times 7 is equal to W, and A times 8 is equal to W. So we can set them equal to each other. A times 7 equals A times 8. And now we're going to solve for H. Divide a 7 to both sides, and H equals, reorder this, 8/7 times A. So now we're going to use this information with our equation here. Okay. Well, two parts. W, we want to get all this in terms of A. So W is equal to A times 8, or 8 times A. Our H value we found to be 8/7 A. We add an A to that, and we still multiply that by time. So now we're going to solve for T time. Well, bring this down, 8A, and then 8/7 A plus 1A is 15/7 A, and now we're still multiplying that by time. If we divide both sides by 15/7 A, that cancels out here, same with our variable on the right side. On the left side, our variable A cancels, leaving us with T equals approximately, or approximate here, 8 divided by 15 over 7, which is approximately 3.73 hours. And there we have our final answer. If they worked together, it would take them approximately 3.73 hours. We're given this problem right here. Working alone, it takes Stephanie 7 hours to clean an attic. Shayna can clean the same attic in 12 hours. Find how long it would take them if they worked together. So let's take what, well, we know. The work of cleaning the attic takes Stephanie, which let's call her variable S, her work rate here is S, and it takes her 7 hours. The same job of cleaning the attic takes Shayna, which we'll say her variable's H, her work rate H, takes her 12 hours to clean the same attic. We want to find how long it takes them if they work together. So the work of cleaning the attic here is equal to, well, there were two work rates together, so we add them up, S plus H, times some time T. All right. Well, notice that the cleaning the attic, they're both at variable W. So we can set these two parts, S plus 7, equal to H time, or S times 7 equals H times 12. Now we're going to solve for S. Divide both sides by 7 here. And S equals, well, let's reorder this, 12/7 times H. And so now we actually have all the information we need, or kind of adapted here. Let's go plug in what we know. I'm going to rewrite this work to be, in terms of Heather's work rate, H times 12. And that's equal, well, I'm replacing S now to be 12/7 H plus 1H times T. And now we're actually going to solve for T here. So instead of H times 12, I'm going to rewrite this as 12H. And then I'm going to add 12/7 H plus 1H, which is a 19/7 H. And don't forget the times T. And now I'm going to get T by itself, so I'm going to divide both sides by 19/7 H. And I'm left with, well, look, 19/7 and the H variable cancel here. H variable cancels here. And so now T is approximately 12 divided by 19/7, which is 4.42 hours. So if they worked together, they could clean the attic in approximately 4.42 hours. We're given this problem right here. It takes Daryl 9 hours to mop a warehouse. Castle can mop the same warehouse in 8 hours. Find how long it would take them if they worked together. So let's write down what we know. Daryl, for working on the warehouse, right, mopping the warehouse, that work takes Daryl, well, his rate, D, times 9 hours. Castle can mop that same warehouse, same work being done, is equal to Castle's rate times Castle's time, which is 8 hours. Okay? And I do find Daryl in the warehouse be kind of funny from The Office. But anyway, I digress. If you know that reference, let me know down below. So, what do we know, what they're asking us here, is how long if they work together. So the same job of mopping the warehouse, we take Daryl's rate plus Castle's rate, and then we multiply that by time. And we want to find what that time is. All right, so the work here, well, for Daryl's, we want to set Daryl's work, basically, into Castle's work, set them equal to each other. D times 9 equals to C times 8, because they're both equal to W. Solving for D, we divide 9 to both sides, and we're left with D equals, and reorder this, 8/9 times C. So now we're going to use that and plug it into this equation, as well as this part with Castle. So the work done is equal to Castle's rate times time, and we'll reorder that to 8C. Daryl's work rate is equal to 8/9 of Castle's. We add Castle to it, his work rate, and then multiply that by time. So now let's go solve for T. 8C stays here, and 8/9 plus C plus 1C is equal to 17/9 C, and that's still being multiplied by time. To get time by itself, we divide both sides by 17/9 C. And what happens? 17/9 cancels, as well as the C value. C variable here cancels as well, and we're left with T going to be by itself, and this is approximately here, okay? 8 divided by 17/9 is approximately 4.24 hours. So that is about how long it would take them if they worked together to mop the warehouse. We're given this problem right here. Working alone, Shanice can tar a roof in 12 hours. One day, her friend Catherine helped her, and it only took 5.14 hours. How long would it take Catherine to do it alone? Okay, so let's write down what we know. The work done of tarring the roof takes Shanice a total of 12 hours. Okay, so the work done times Shanice's rate times 12 hours. Okay, then her friend Catherine, her work rate we can call a variable K, her work rate, and then times time. We don't know what those are. What we do know is when they work together, so doing the same job, we have S plus K, took them a total of 5.14 hours. And we actually have now the 3 equations we need to solve this. So let's simplify what we know. Well, our work is equal to Shanice times 12, or 12 Shanice, write it that way. And I'm going to distribute this 5.14 to both parts here. I have 5.14 S plus 5.14 K. Now I want to get K, or S really actually by itself, sorry. I'm going to subtract the 5.14 S to both sides to combine the like terms here. I know my S's are a little weird. 12 divided by, minus 5.14 S, subtracting here, is 6.86 S, and that's equal to 5.14 K. I'm going to divide a 6.86 to both sides here, leaving me the variable S is equal to, okay, 0.74927 K. So what do we do with that? Well, let's look at this formula for Shanice. W equals S times 12. I'm going to plug this in for S. 0.74927 K times 12. And I'm going to keep going here. And the work equals, well, let's take that 0.74927 times 12 and put the K out first. And that multiplied out comes out to be about 8.99. And so if we look at the formula for Catherine, we can see that, well, her time, whatever her work rate is, we don't really know right now, but whatever it is, it takes her a total of 8.99 hours, right, to complete the job. So our answer is 8.99 hours, and that's how long it would take Catherine to do it alone. We're given this problem right here. Nicole can pick 40 bushels of apples in 15 hours. Carlos can pick the same amount in 11 hours. How long would it take them if they worked together? So our work here for them is picking 40 bushels of apples. So that work there, 40 bushels of apples, is equal to, well, Nicole's rate times Nicole's time, which is 15. They tell us that Carlos can pick the same amount, so 40, equals Carlos's rate, which we don't know, times his time, 11 hours. And we want to find out what happens if they work together. So the job is still the same work of 40 bushels of apples. If they work together, we add their rates, n plus c, and we need to find its time. Okay. Well, how do we solve this? Well, we can find each one's individual work rate. We divide 15 to both sides, and n equals 40 over 15. And that's Carlos's work rate. Oh, sorry, Nicole's work rate. Do the same thing here, divide 11 to both sides. And Carlos's work rate is 40 over 11. So we can plug those two values in right here for n and c. So 40 equals n, which is 40 over 15, plus c, which is 40 over 11, Carlos's work rate, times time. We add these two together, and 40 equals, well, 40 over 15 plus 40 over 11 comes out to be a 208 over 33, and we're multiplying that by time. We divide this big fraction, 208 over 33, to both sides. These cancel, and we're left with time going to be by itself. It's approximately, and 40 divided by 208 over 33 is approximately 6.35 hours. So, if they work together, they could pick 40 bushels of apples in 6.35 hours. We're given this problem right here. Working together, Arjun and Maria can oil the lanes in a bowling alley in 4.24 hours. Had she done it alone, it would have taken Maria 8 hours. How long would it take Arjun to do it alone? Alright, well, let's break down what we kind of know here. The work, let's do it individually, is equal to Maria's rate times, and they tell us it takes her 8 hours. Arjun's we don't know. Whatever the work is, which is oil the lanes of a bowling alley, is equal to Arjun's rate times his time. The first thing they give us here, though, is what happens when they did it together. So that same work, again, oiling the lanes of a bowling alley, is equal to Arjun's rate plus Maria's rate times a time of 4.24 hours. So now we're going to use this and adapt it and see if we can solve this equation here. All right, so this work, let's replace it with Maria's, m times 8, or 8m here. It's the same thing. We're going to distribute the 4.24 to both parts here. And we have 4.24 times Arjun's rate plus 4.24 times Maria's rate. We then are going to subtract a 4.24m to both sides. And we're left with 8 minus 4.24 is 3.76 times Maria's rate is equal to that 4.24, 24. Times Arjun's rate. Divide both sides by 3.76, and we get Maria's rate is approximately 1.1277 times Arjun's rate. So how does that help us here? Well, what we're going to do is actually, we're going to take this right here, and we're going to substitute, instead of m, this decimal, 1.1277a. So the work here is equal to 1.1277, 1277a times 8 hours. And what happens here? Well, I'm going to rewrite it. It's all multiplication. Let's put a first. And 1.1277 times 8 comes out to be approximately here 9.02. And so we can see that now with our formula for Arjun's work rate. The time there is 9.02. So 9.02 hours is how long it would take Arjun to do it alone. We're given this problem right here. Working alone, Eduardo can harvest a field in 14 hours. One day, his friend Amy helped him, and it only took 7.47 hours. How long would it take Amy to do it alone? Well, what do we know here? The work of harvesting a field takes Eduardo, so whatever his rate is, times 14 hours. We don't know much about Amy, so her work, whatever it is, of harvesting the field is equal to Amy's rate times her time. Okay. But we do know how long it takes them if they did it together. So that same work of harvesting the field is equal to Eduardo's rate plus Amy's rate, and it took them a total of 7.47 hours. So what are we going to go from here is we're going to adapt this stuff and see if we can get an answer. So we know the work is equal to E times 14, or 14 times Eduardo's rate. We're going to distribute the 7.47 to both parts here. 7.47E plus 7.47A. Now let's combine our like terms. I'm going to subtract the 7.47E to both sides. And what am I left with here? Well, 14 minus 7.47 is 6.53, and don't forget the E. And on the right side we have 7.47A. To get E by itself, I'm going to divide both sides by 6.53. And E is approximately equal to 1.144A. So how does that help us? Well, our formula for Eduardo here, we're going to take that E and replace it with 1.144A. So the work here now is approximately 1.144A times 14. If we rearrange this formula, because it's all being multiplied, so we can rearrange it. If we put A first and multiply 1.144 times 14, we get a rounded answer of 16.02. And we can see how that lines up with our formula for Amy. So Amy's time, we can see now, it would take her 16.02 hours to harvest the field. We're given this problem right here. Working alone, Mary and Trayvon can inflate 20 balloons in 7.34 minutes. Had he done it alone, it would have taken Trayvon 14.1 minutes. How long would it take Mary to do it alone? Okay, so let's write down what we know. We know the work of inflating 20 balloons is equal to Trayvon's rate times 14.1 minutes. They tell us if Mary had done it alone, well, that's what we want to find. So the work is equal to Mary's rate times time. So we don't really know that information there. But we know that if they did it together, the work of 20 balloons, and we had Mary's rate plus Trayvon's rate, it took them a total of 7.34 minutes. Okay, so where can we go from here? Well, this equation, kind of wrote it kind of close here, but 20 equals T times 14.1. Let's go find Trayvon's rate. Trayvon's rate is equal to 20 over 14.1 here. And that's going to be helpful. So we're going to take that and we're going to substitute it in for T right here. So we have 20 equals M plus 20 over 14.1 times 7.34. And now we have enough information to solve, well, for M. I'm going to divide, so this is multiplication, divide both sides by 7.34. I'm going to have a lot of decimals here. And so we have 20 over 7.34 is equal to M plus 20 over 4.1. And then I'm going to subtract a 20 over 4.1 here to both sides. And make sure you keep everything lined up. And we have, well, Mary's rate is going to be approximately, okay, so it's going to be by itself now because this will cancel. It's approximately in 20 over 7.34 minus 20 over 14.1. Oof. If you caught that mistake, let me know. Be careful. Sorry about that. This is 14.1 down here in the denominator. So make sure you fix that or add that if you've been following along. Sorry about that. But we all make mistakes. All right. So give me a like for that. Not just show all the good stuff. All right. Well, that comes out to be, when we subtract them, approximately 1.306. All right. So what can we do here? Well, we know Mary's rate here. When we found Mary's rate, and we actually know the work is going to be 20 balloons. So 20 balloons is equal to 1.306 times, and we're substituting that in here. So now time by itself, we divide by 1.306 to both sides. And Mary's time it takes her to blow up the 20 balloons, inflate 20 balloons, is approximately 15.31 minutes. And that is our final answer. We're given this problem right here. Shreya can weed a garden in 19.3 minutes. One day her friend Eliza helped her and it only took 7.44 minutes. Find how long it would take Eliza to do it alone. Okay. Well, we know the work of weeding the garden, both being W here, takes Shreya as her rate times 19.3 minutes. Eliza, we don't know, so the same work, Eliza's rate times. Now they tell us though, if they did the same job of weeding the garden, it takes them 7.44 minutes. So we add their work rates together, S plus E, times that work time of 7.44 minutes. So let's just adapt this sum. We can replace our work. We know it's equal to Shreya's rate times her time. So let's put the time first, 19.3 S. And let's go distribute the 7.44. We have 7.44 S here plus 7.44 E. Combine our like terms, we subtract a 7.44 S to both sides. And we're left with, well, 19.3 minus 7.44 is 11.86 S, and that's equal to that 7.44 E. Divide both sides by 11.86, and we get the variable S by itself, which is approximately here 0.6273 times Eliza's rate. Okay. Well, now what we can do is we're going to take the formula here from Shreya, and we're going to plug in what we know here. So that work is equal to Shreya's rate is equal to 0.6273 times E times the time of 19.3, if it fits in here. 19.3. Oof, barely fit that in. How's it fit? Okay. Let me erase that just in case it didn't. I'm going to rewrite that because I don't know if it's going to be off screen. I would hate for it to be. So sorry if it was, but so that work equals, we're going to replace Shreya again, 0.6273 E times 19.3. All right, that should be on. Okay. So what do we do from here? Okay, we're going to reorder this so it looks more like this formula. E comes first, and we can do that because it's all being multiplied. And what's 0.6273 times 19.3? Well, that's a 12.11, or 12.11. So it takes Eliza 12.11 minutes to weed the garden by herself. We're given this problem right here. Hyung can wash a car in 10 minutes. One day her friend Castle helped her and it only took 6.67 minutes. How long would it take Castle to do it alone? So let's write down what we know in formula form. The work done of washing a car takes Hyung, her rate, times 10 minutes. We don't know Castle's, so the same work takes Castle, that's Castle's rate, times time. Don't know that. But they tell us if they work together. We know that time. So the same job, if they work together, H plus C takes a total of 6.67 minutes. Okay? So let's replace what we know. We know W is equal to H times 10, or 10 times H. We can distribute the 6.7 to both parts. So we have 6.6 or 6.67 H plus 6.67 C. Now I'm going to combine my like terms, subtract the 6.67 H here to both sides. And 10 minus 6.67 is 3.33 H, and that's equal to 6.67 C. If I want to get H by itself, divide both sides by 3.33, and H is equal to 2.003 C. So how does that help us? We take the formula for Hyung, and we can replace H with 2.003 C. So that work is equal to 2.003 C times 10. Okay? So watch this. That same work, since this is all being multiplied, we can reorder that. We'll put C first and multiply that by 2.003 times 10, which is 20.03. And now we can see how this matches up with our formula for earlier. Our time here for Castle is 20.03 minutes, and that's how long it would take Castle to wash the car. We're given this problem right here. Working together, Kim and Jennifer can install a new deck in 6.28 hours. Had she done it alone, it would have taken Jennifer 13.7 hours. How long would it take Kim to do it alone? So what do we know? Well, we know the work done of installing a new deck, which I think these are low estimates, but it's okay. Having done it myself, the work done by Jennifer, so work equals Jennifer's rate times, 13.7 hours. So it only took her 13.7 hours to install a whole deck. Again, don't trust that. Unless you're really, really fast, I guess. We don't know Kim's though. So Kim, work done of installing the deck is Kim's rate times Kim's time. But what we do know is when they worked together. So the work done of installing the deck is Kim's rate plus Jennifer's rate times a time of 6.28 hours. Okay? So now we're going to adapt this sum. We know this work is equal to J times 13.7. So I'm going to rewrite this as 13.7J, flip it around. And I'm also going to distribute the 6.28 to both parts. 6.28K and 6.28J. Now I'm going to combine my like terms, so I'm going to subtract a 6.28J to both sides. And that comes out to be, well, this cancels. And 13.7 minus 6.28 is 7.42J. And that's equal to the 6.28K. And now I'm going to get J by itself. So divide both sides by 7.42. And we have J is equal to 0.8464K. So how does that help us here? Well, notice our formula for the work for Jennifer. Instead of J, Jennifer's work rate, we can write it in terms of Kim's work rate, which is 0.8464 times K, Kim's work rate. That's equal to Jennifer's work rate times the 13.7 hours. Okay? Well, the work here is equal to, since it's all multiplication, we can rearrange this. Let's put K first and multiply it by, well, it's 0.8464 times 13.7. That's going to be approximately 11.60. And so notice how it matches up with the formula for Kim's work. The time it takes, whatever Kim's work rate is, it would take her 11.6 hours. So 11.60 hours, but 11.60 hours is now how long it would take Kim to install a new deck. I hope this video was helpful, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.